Hey, hello, how are you? My name's Anna Tenbenzel. Welcome back to my channel. I am on question, well, I've done 86, but I am on question 45. Alrighty. So let's see. Jump game 2. Okay. So I am on question number 45 of this LeetCode problem set called Jump Game 2, and this solution is going to be in Python. I have not read through this question yet, so let's go ahead and read through it together. If something sticks out to me, then I will say it, but chances are we're going to have to read through this once or twice. So, jump game 2. You are given a zero-index array of integers of length n. You are initially positioned at num0. Each element nums I represents the maximum length of a forward jump from index I. In other words, if you were at nums I, you could jump to any nums I plus j, where 0 is greater than or equal to j, less than or equal to j, which is less than or equal to nums I, and I plus j is less than n. Return the minimum number of jumps to each nums minus 1. The test cases are generated such that you can reach nums n minus 1. And let's look at these examples here. So you have the nums 2, 3, 1, 1, 4. The output is 2. The maximum number of jumps to reach the last index is 2. Jump 1 step from 0 index to 1, then 3 to the last index. And we have constraints here. It's guaranteed that you can reach nums n minus 1. Okay, so given a zero index array of integers, nums of length n. I mean, the immediate thing, if you're already at the destination, because you have to jump to the end, right? You have to jump to the destination. If you're already at the end and there's only one element, then we should just return 0. That would be like the first thing for the smaller or like edge cases. But in terms of method, I think the first thing that's kind of popping out to me here is like a greedy approach to find the minimum amount of jumps needed. Because I think that would be the best way to keep track of those maximum, that maximum reachable index, or I guess for our sake we could call it next max. So yeah, we can just kind of break it down into a loop, but my first instinct is to use greedy and then just to immediately declare that if there's either only one element or it's final, like they're at their, or they need to be at the end, then we just return 0 because it's already done. So I'm going to read through this one more time just so I'm making sure I'm getting all of this, but that was just based on the first read here. So you are given a zero indexed array of integers nums of the length n. You are initially positioned at nums 0. Each element nums I represents the maximum length of a forward jump from index I. In other words, if you are at nums I, you can jump to nums I plus j. And then we have these return the minimum number of jumps to reach nums n minus 1. So I mean, the minimum should be the maximum, right? So we should be initializing it in a way that the max is the min. So actually, let me start with this. And if n, this was just going to say that if we've reached the end and there's nothing to jump over, then it's just returning 0. So I'm going to initialize the number of jumps. So I'm going to say jumps equals 0. And then I'm going to say the current maximum index that can be reached with the current jumps. We're going to say current max. And the reason I'm going to do this current max situation is so that once we reach that last index, we can say if current max is greater than or equal to n minus 1, then we can break and then return the jumps. And then we're also going to initialize for the maximum index that it can reach with the next set of jumps, but we're all initializing it to 0. So we're going to then break it down to, for I in range, I'm not sure what I should do exactly. If I is greater than the current max, so if the index is greater than the current max, then the jumps are 1, and then the current max becomes the next max. Make sense? So that the next max is the max of the next max plus the index plus nums I. Max of next max, and then I said I plus nums I. So then if current max is greater than or equal to n minus 1, like I said before, then we've already reached the limit of that last index and we can exit the loop. Right? And then we just return jumps. Yeah. So instead of trying to scrape by the minimum, we just go for the max of what we can do and then break and see. That means if we need an additional jump, we can update the current max to next max. So we set it so that the first jump would be considered the max. But if we can do another jump, then we're going to update that max. I don't know if that actually makes sense logically, but it makes sense in my head just from reading this, 8 minutes ago. That way that, like, the loop could continue. So I don't want it to be like, oh, it's the max, like, that's it. Like, we just continue until we reach that last index. And then at that point, then we just return the number of loops. But we figure out how many jumps we need. Because that just to me makes sense. We're just going to go ahead and run it. Because if it's wrong, then we can just update it accordingly. But it's not. But it's not, though. Let's submit it and see what's going on. Okay, runtime beats 80% of users with Python, but my memory does not. Which makes sense, because we're putting a lot of stuff in a lot of places. I'm kidding. But overall, okay, the memory is 14.4 megabytes, so it's not the worst. But I definitely think this greedy solution could be improved, or this greedy approach, rather, could be improved through this solution. So I'll probably be revisiting this one later on down the road, because I want to bring this back up. I want to hit to 50 and above. But overall, I'm actually pretty impressed that my brain was able to deduce that as quickly as it did. And yeah, so I'm going to take this and I'm going to put it in my GitHub repo that I have all of this stuff in. I have all the video tutorials, I have all the code. So you guys are more than welcome to fork and clone it, make it better, make it worse, have some fun, learn something new. And thank you guys so much for watching. I will see you guys in the next video. Thank you so much.